Hello, Algebra 2. It's 2.3 word problem day, part 2. So what should have happened yesterday is you should have worked from 1 to 8. On any of these, if you check your answers in the back and you're getting the odds right, you're probably good on the evens. But just in case, for number 2 yesterday, we'd be shooting for 4 and 6 to be answers. For number 4, we're after 1 and 7/8 versus 3 and 1/8. 6, you'd have to round to the nearest cent and have $14.13. Number 8 should have turned out to be 8. Today what we're working is problems 9 through 22. So I have a little bit of examples here on the board to do one of each type. I'll also point out that some of the hints I'll drop you are located on page 67 as well. So if you're short a hint or miss a hint, page 67 in a box has some hints for the problems we're doing today. But 68, 9, 10, 11, 12, and then later 19, 20 are all going to be percentage problems. So here's the way you want to work percentage problems is start from 100%. If they talk about an increase, you want to add on. If they talk about a decrease or they put something on sale, we want to subtract off. So if I say to you, we're going to a restaurant, we get our bill, it's 7% tax, you'd want to add on 7%. Take your 100, always, percents are always out of 100. So take 100, add on 7, and now we're looking at 107%. Percentages to be useful always have to be made decimals. To make percentages into decimals, you take the invisible decimal that's here and go left 2 places. And we'd be looking at 1.07 as our magic number if this were an increase problem. So sales tax, leaving tips, anything that's an increase, we take 100, add on the amount, get a decimal. And then here's another thing about percentages, other than always wanting to make them decimals, they always multiply. Percentages always multiply. So in a story problem that involved a 7% increase, we'd want to be multiplying something by 1.07. If we have a decrease, a sale or whatever, you go to the store and something's on sale, 20% off, take your 100, subtract 20. Now we're looking at paying only 80% of the dollar value. But always make percentages decimals. Take the invisible decimal, go left twice. We'd be looking at 0.80 or 0.8 if you prefer. That would be your magic number for doing the story problem. And again, percentages always multiply. Even more specifically, percentages always multiply the original price to cause a new price. So if the original price were 70, we would take 1.07 times 70. If the final price is 70, we'd have to take 1.07 times an unknown variable and let it equal 70. Okay, so percentages always multiply the originals to make the final. And here we go on number 9 using that trick. So number 9, it says, we're in a bowling alley, we drop the price 24%. So we would take our 100, we'd reduce our price by 24%. So you're paying 76% of your price. As a decimal, that's 0.76. 0.76 has to multiply the original price of the bowling ball. And that's going to equal the final price of the bowling ball. So I'm going to go back and read the story in a second, but my first thing to skim for is just the percentage number and do the process to figure out what decimal is going to be multiplying our original price. So on number 9, they say a bowling ball, we drop the price 24%, the sale price is $34.50. What was the original price? So the original price is what always multiplies our magic number. We don't know that, so we're going to do an X there, and then we are going to do the $34.20 later. Now, if you got those crisscrossed, it would show up in terms of the final thing I encourage you to do in these stories is think about whether this answer makes sense. Okay? So if you did 0.76 times the 34, you'd have come up with an original price of $25. Okay, that doesn't make any sense. It doesn't make any sense that you'd have an original price of $25 and it goes on sale and it's $34. If you think that's reasonable, I'd like to open a store and have you over every time I have a sale, because that just, you're gonna get burned by people. We have to get a number that started off higher than $34. I'm gonna leave this to you to solve. You know, do your opposites, solve it. You should get an answer that's above $34. If you worked this problem and you thought the bowling ball cost $3,000 or something, you obviously did something wrong. Like if it's on sale for $34, it needs to cost more than $34, but not like ridiculously more than $34. So that should take you again, 9, 10, 11, 12, 19, 20, those are all percentage problems. Sales here, raises there, whatever. So again, hundreds, plus for increase, minus for decreases, get it converted to a decimal. The decimal number multiplies the original price, and that's going to equal some final price, and you're going to know one of those two items. 13. 13, 14 are about the same as each other, but completely different from the other thing. So 13, 14, back to advice from yesterday. When you can, to help you get organized, draw a picture. And this, since they're talking about triangles, I'd highly suggest that you draw a picture on this one. So this, it says the second angle of a triangle is 3 times the first. The third is 12 less than twice the first. Find the measures of the angles. So one thing you want to realize out of the gate here, first of all, we're looking for 3 answers. We're not looking for one answer. We have 3 angles in this triangle. We need to get all 3 answers eventually. Another thing you want to try to recognize is everything here was explained in terms of the first angle. Second was 3 times the first. Third was 12 less than twice the first. The first is the foundational place to start. So it doesn't matter which angle you call your first angle. I'll just pick that one, I'll call it X. That's my first angle, I know nothing about it, I'll just call it X. Then I need to pick an angle to be my second angle. It doesn't matter which one I pick, but it says that the second angle is 3 times the first. Well, since we called this X, this one needs to be 3 times the X. So that's what I'll call that one. Then for the third, it's 12 less than twice the first. A lot of people for 12 less than are tempted to do something like this, which is not correct. Less is a subtract word, but the phrase less than is the one word phrase in math that causes an order reversal. So if we say 12 less than something, it's not that. 12 less than something always looks like 12 being subtracted from a different item. So we're 12 less than twice the first. I need to go 2x minus 12. Since the first one was x, twice x is 2x, and then 12 less than that, I'm going to go with the minus 12. So picture accomplished, triangles, there we are. To make an equation, you're going to need to know a fact from, for sure, 7th grade math and geometry, maybe even elementary school. I don't know, I don't teach elementary school. But you need to know the fact, and it's in the blocks on 67, that in a triangle, the angles have to add up to make 180 degrees. So when we go to create an equation for problem number 13, we're going to go x plus 3x plus 2x plus 12 equals 180. This one, plus this one, plus this one. Oh, that wasn't a plus 12, it's a minus 12. Almost made a mistake on the video. Minus coming with us. So the x, the 3x, the 2x minus 12, add that all up, that equals 180. If you're going to solve this, you're going to need to combine some like terms. You're going to need to do some opposites, add the 12, divide by whatever number you get with x's, remembering that has an invisible 1. I'll leave that to you to do for the homework. Eventually, you get an answer like x equals whatever. Let's say, 10. That's wrong. It's not 10. But let's say you solve and you get x equals 10. Remember, our goal was not to get one answer. The goal was to get 3 answers. So if you get an x of 10, that's telling you what this corner is. That's 10. To figure out this corner, we have to do 3 times 10. That would be 30. To do this corner, we go 2 times 10 is 20 minus 12, that's 8. That's clearly a wrong answer because that adds up nowhere even close to 180 if we were dealing with a 10, a 30, and only an 8. So let algebra take you on a guide here, get a solution, whatever you get, that's one of 3 answers. 3 times that's an answer, 2 times that minus 12 is an answer, but make sure those answers add up to 180. If those answers don't add up to 180, you did something wrong, and then you need to go try back from the beginning. 13, 14, same kind of stuff. 15, I would draw a different picture. 15 is talking about perimeters, so I would draw myself a rectangle for 15, a rectangle for 16. They've got 15 is a basketball court, 16 is a soccer field, so those are both definitely rectangles. They say the perimeter is 96, so when we go to write our equation, a bunch of stuff is going to have to add up to make 96. That's how perimeter works. You add everything up around the whole shape, and it adds up to 96. They tell you the length is 14 more than the width. It doesn't matter for a rectangle which one you call the length or which one you call the width, because like right now you might want to argue that that should be the width of the rectangle because that's how wide it is. But then if I go like this, it's no longer true. Okay, so it doesn't really matter. Okay, which is not important. But they're telling us that one of these is 14 more than the other one. So there's always some sort of a thing on your picture that you want to just call X, just to get yourself started. Just pick a letter, any letter, throw it on your picture. I threw that on the shorter side, but it's not super important either. The longer one was 14 more. More is an add word. So this is going to be 14 more than an X. And then the way rectangles work, this would be a match for the original X. This would be a match for the 14 plus X. And if you added this in a different order, that wouldn't matter. You can add in any order you want. That's the commutative property back with us. These all have 1s. So if we add everything to get the perimeter, there would be 4 of the X's plus 28. And then I'll leave it to you for homework to finish that. Do opposites. Subtract the 28. Always add or subtract first. Divide by the 4. See what you get. This is a wrong answer. Let's say if I got X equals 3. To finish this problem, they ask us for what are the dimensions, plural, more than 1, 2 of them. They want the length and the width. So if your X is 3, that's telling you this one, because that's the one we called X. Then this would be 14 plus 3 is 17. But that's wrong, okay? Because if you did 3, 3, 17, 17, that's nowhere close to 96. It's not a right answer. But that's how you finish the problem. Once you get your X figured out, you're going to grab it as one answer, 14 more than it is your other answer. Next problem to get you started on is 18. 17, 18 are the same as each other, and these have a trick from Algebra 1. Anytime they're talking to you about consecutive integers, you just call the first one of your list X. The next one is X plus 1. The next one is X plus 2. If you need more, it would be X plus 3, and you make a list of names like that as long as you had to make a list. If they say to you something about consecutive evens, you still call the first one X. But your next even number is X plus 2 to get 2 away, because the evens come every other number. Then there would be an X plus 4 more, then an X plus 6, and then so on and so forth as far as you needed to go. If they told you consecutive odds, this is the one where people sometimes fool themselves. It's the same exact list, because to get from one even to the next even, they're spaced by 2's. To get from one odd to the next odd, they're also spaced by 2's. Sometimes people want to do stuff here with X plus 1's and X plus 3's, and that's wrong. Because if you start with an odd, and you add on a 1, which is another odd, this would be odd, this would be even, and that's not the kind of thing we're trying to build. Odd and even use the same exact list, and I think they dropped that hint on the box on the page that I referenced a minute ago. So let's see what type 18 is. 18 says find two consecutive evens. Since they said consecutive evens, I'm going to use this list. They only mentioned two of them, so these are the names of the numbers that we're dealing with. If they said consecutive odds, I would have done the same list. If they said just plain old consecutive, I'd have grabbed those two names for my numbers. So 18 says find two consecutive evens such that 2 times the first, so that needs a 2, plus 3 times the second. To keep the second one as a group, I need parentheses. So 3 times the second is always an equal sign, and the 76 at the end. And then I'll leave that to you to solve this one for homework. You'd have to do a distribute, you'd have to do a combine like terms, you'd solve. Let's say you got x to be 5.5. 5.5 is crazy because that's not an integer. This has to be an integer. They told you it was going to be an integer. If you don't remember integers, integers are my number line marked numbers. The positive versions, the negative versions, and 0. All of the whole numbers and the negative whole numbers, 0 included, those are the integers. If you solve this and got x to be 7, that's crazy because this question said even integers. So if you solve this and you get an odd, there's no way that's right. The only way you have a chance of being right is if you solve for x and x is an even integer. Let's say hypothetically I get a 4. What they're going to want is not just the one answer but 2 answers. This might have had a shot because at least it's an even integer, but this is another wrong sample. But if 4 were right, you'd be thinking about 4 and its friend 6, because 6 is the next number up. But to check this isn't right, because if we do 2 times the first one, that's only 8. 3 times the second one's only 18. Together, that's nowhere close to 76. Algebra is going to probably have to take you somewhere here, like into the teens. So you'll probably get an even teen. Say it's 14, then 16 is its friend. Or if it's 16, then 18 is its friend. But we need a number like that where 2 times the first one plus 3 times the second one does indeed make 76, and I'll leave that to you. 17, 18 are the same. 19, 20, I'm not doing anything because I already talked about the percentage trick. Okay, number 9 at the very beginning, 19, 20, it's working the same type of percentage problems. 21, 22 are the same as each other, but a whole new type. So for 21, it says here to start with, the tuition cost plus the room and board cost at some school is $25.84. So what I would do is just start off making an equation from that sentence. They're talking about the tuition cost, I'll do T for tuition, plus the room and board cost, I'll do R for the room and board, is, so equals, $25.84. You haven't seen too many things like that in your math lifetime as a first chapter Algebra 2 student, because there's 2 variables. You're used to having 1 variable, and that's always our preference, is to have 1 variable, not 2. But based on what I read so far, that's all I can really do. I don't know what the tuition is. I don't know what the root and board is. I know if I put them together, I'll make $25.84. I just have to hope there's some more information coming in this sentence. And there is. So we're going to make a switch up here in a second. In the second sentence, they say that the tuition is $704 more than the room and board. So I can make a trade here. Since the tuition is the same as $704 plus the room and board, I can cross out my T for tuition and do $704 more than the room and board. That's a fair trade. Tuition is the same as $704 more than room and board. But this is still here, okay? So the tuition plus the room and board had a relationship. The tuition can get thrown away in replacement for this. And now this is solvable. There's one of these here, there's one of those there. We've got 2 room and boards plus 704 is $25.84. And I'll leave that to you to go from there. Subtract, divide, figure out what it is. let's say room and board is $500. They want both answers, I believe. No, they don't. They just want the tuition. So we're off the hook on this a little bit. But they're asking for the tuition. So when we solve this, we're going to get an R answer for room and board. So if we get a room and board answer that's like 500, and I don't think that's going to be right, 500 can get put back in here. 704 more than that, that's the tuition, that's what you're after. So if the room and board is 500, your answer would be 1204 for your final answer, because we're going to want to go 500 plus the 704. So whatever room and board does for you, that plus 704, that's where we want to finish to answer the tuition question, and that's what 2-3 is about. So you're just working here from 9 to 22. I got you started on 5 of them. It's up to you to finish those 5, but also get those other ones started and do the full process the way these were going. So if you have any questions, email me. We'll set up a Zoom meeting to talk.